Hello, Year 12. I hope that you're well. Right, a couple of people have said that they found question 4b confusing, so I'm just going to go through it step by step. Please email me back if anything doesn't make sense. Okay, a particle P moves in a straight line so that at time t equals seconds, its velocity v is given by. The velocity is given by 7t minus t squared. So this is how we're going to model the velocity between the times of t equals 0 is greater than or equal to 0 or less than or equal to 5. So for the first 5 seconds, this is how we'll look at it. And then from any value where t is greater than 5, I use this one. So basically, I'm going to have to split this in because there's two different models I'm going to use. I'm going to have to split this into two separate parts when I look at part B, and I'll explain that in more detail in a second. Find the total distance travelled by P in the first 10 seconds. Well, I can't just look at this one and look at it between 0 and 10 because I know that this only applies for the first 5 seconds. Therefore, let's have a think about what we know. Well, I know that if I integrate an expression for the velocity with respect to time, that's going to give me the displacement, i.e. the displacement is going to be this expression integrated 7t minus t squared with respect to t, or s equals 7t squared over 2 minus t cubed over 3 plus c. Problem. I need to work out what that constant is, don't I? Well, if I think about this, I know right at the beginning of the journey, I know that t equals 0. Let me write that underneath so it doesn't look confusing. I know at the beginning t equals 0. And because I want the distance, or in this case, the displacement for this part of the journey, which I will then make the distance essentially, because I'm only looking at this period of the journey, I'm going to say that it hasn't moved anything at this point because I want all of the distance that it covers from there. So I'm just going to say that that bit's 0 as well. And then when I substitute those two things in, t equals 0 and s equals 0, it's going to mean that c equals 0. So in fact, the way that I can model this here will be s equals 7t squared over 2 minus t cubed over 3. Then what am I doing? Well, that's my integrated expression, and I want it between 7t squared over 2 minus t cubed over 3, and I'm looking at that between t equals 5 and t equals 0. Well, hopefully we can see that if I put t equals 0 into that, because there's t's in each of these terms, I know that when t equals 0, it's just going to be equal to 0. So all I'm basically going to be left with is 7 lots of 5 squared over 2 minus 5 cubed over 3. So that's it when t equals 5, and when t equals 0, I know that expression is just going to equal 0. Therefore, it's going to leave me with, for this bit, s equals 275 over 6. So that's how much the displacement is, or how much distance essentially it's covered in the first part. Okay. Now the second part is a little bit more confusing. I know from t is greater than 5, so I've now looked at it between the times of 0 and 5. Now I'm going to look at it between the times of 5 and 10. Well, I know for anything where t is greater than 5, I need to use this one. So for this one, I know that v equals 10 minus 2t. And if I integrate that expression there, it's going to give me an expression for the displacement between those times. And that's going to give me S equals 10t sorry, let me tidy that up. 10t minus 2t squared, 2t squared over 2, so that's going to be minus t squared. And then again, I've got my plus c. Now, I'm almost treating this as a whole new kind of journey. I'm going to say, well, I worked out the displacement for the first bit. Now I'm going to treat it afresh for the second part of the journey. So I'm going to say when t equals 5, when t equals 5, well, I'm going to say for this part of the journey, because I want the displacement from this point on, I'm going to say that the displacement is 0. Yeah, and then I can work out the displacement for this part of the journey and add it onto my value for my displacement for the second part of the journey, the distance for the second part, the first part of the journey. Okay, right, so what are we going to have? So when I put all those things in, I'm going to get C equals minus 25. So I know that my expression for the displacement is going to be 10t minus t squared minus 25. Now I'm going to look at that because I want it up until 10 seconds. I know that this is my already integrated expression to get me the displacement. And for this bit, I'm looking at it between t equals 10, t equals 5. Right, let's substitute in those two values now. So I know that 10 lots of 10 minus 10 squared minus 25. And then minus 10 lots of 5 minus 5 squared minus 25. Or if I work out all those first things, that's going to give me 25. And randomly, when I put this in, 50 minus 25 minus 25, that's going to give me 0. So I know that for the second part of the journey, the displacement is 25. And therefore, in this case, the distance is also 25. So add those two values. This is the distance covered in the first bit. This is the distance covered in the second bit. 275 over 6, add 25. It's going to give me a total distance covered of 425 over 6. Okay, please email me if that doesn't make sense, guys. Thanks a lot for your time. Bye.